Well, welcome to the Manana Ventures YouTube channel. I am your tutor, Figastorm. Today we will be doing the topic of centroids, aka center of gravity. Please like and subscribe to our channel. Let's go to the question now. The question is, the figure below shows a plane lamina. Calculate the centroid of the lamina. Lamina is this whole shape that you can see there. It consists of triangles, rectangles, as well as half circles. Now there are a few things that you need to know before you tackle this question. The first thing you need to know is the individual centroids for each of the shapes. Let us start with a triangle. The triangle centroid is located right there. From the bottom, it's at a distance of half h, h being the total height. My bad, it's one third of h, not half. And then from this side, it's also a third, 1/3 length. It's called the length, that whole section there. And for a circle, we have a circle, centroid is right there, okay, and it's at a distance of r. But for a half circle, it's somewhere there. So that's a distance of r, which is the radius. But going up, it's 4/3, okay, r over pi. All right, and then the last one is a rectangle. The centroid is right there at a distance of a half of the length and a half of a height. Those are the few basics that you need to know to tackle this question. Now, we have a table to fill up. There's our table. It consists of the shape, the area, the centroid of the individual shape on the x-axis and on the y. And then we have the moment here, which is the area times the centroid, as well as here. Okay, let's start with shape A. If we go to shape A, as you can see from my lamina, it is a triangle, okay? And we know that the area of a triangle is equal to half base times height. So what are we going to do? We're going to take a calculator and put this into a calculator. We're going to say half, let's switch calculator on, which is 0.5, times the base. Our base is 30, times 30, times the height, of 35, and we get 525. Take that answer, put it 525 right there. The next shape is B. B is this entire rectangle, which is 40 times the distance of 40 again, which is 35 plus 5, it gives us 40. We put that in our calculator. We get an area of 1,600. Take that and put it there. Okay, now for C, we go to C. C is a triangle. In our area, once again, half base. Our base is 15. Times a height of, we're given a height of 10. We get 75. Now, what you must know is, if you have a shape within a shape, that shape is hollow. So, since this is hollow, C is hollow, we put it as negative. It has a negative area. It's an empty space. Okay. But if you have a shape besides a shape, besides a shape, besides a shape, then you add that one. But if it's within a shape, then it's always hollow. Okay, now let's go to D. Where is our D? D is there. Okay, the area of a circle is pi r squared. But the area of a half a circle is still pi r squared, but it's divided by 2. So, since D is a half a circle, we're going to say pi times our r, we given as 10 squared, divided by 2. We get 157. We'll go ahead and put it right there. 0.08. And then now we go to our shape, which is E. It's also half a circle. So we're gonna just say pi times our r, we're given an r of 20 squared divided by 2. That gives us 628. Take that 628.32. Okay. Now we need to find the individual centroids on the x-axis. Starting from, this is our datum, 0. So everything will be based on that. Okay, so the centroid of A is a triangle, and if coming from this side is 1/3, then coming from the apex this side, it is 2/3 times L. Likewise, up there, it's going to be 2/3H. That's the distance from here to here, and here to there. And we have that situation here where the centroid of this triangle is somewhere here. So we're going to take our calculator and we're going to say, okay, 2 divided by 3 times a length of 30. And we get 20. Take the 20, write it down there. Okay. Now, B is a rectangle. Okay. And the centroid is at half its distance, as we had said there. So, half of 40 is 20. It's 20 there. So we're going to say 20, but to take us back to the datum, we need to add this 30. All right, so it's 20 plus 30, which equals 50. Take that 50, write it down there. Okay, that is our B. And for C, our centroid is also there. Okay, so we're going to take half of 15, which is 15, all right, divide by 2, we get 7.5. So it's 7.5 there, but we need to add this 10 and add that 30. So we're going to say plus 10 plus 30, we get 47.5. Take that 47.5, put it there. Okay, now C, we're moving to D. D, the centroid of D is just a radius of 10, so it's somewhere, it's there. So it's 10 plus, to take us back to the datum, 30. That's 40, which gives us 40. Write the 40 there. And of E, remember we spoke about it. That's the centroid is somewhere there, but that distance from there to there is given by 4r over 3 pi. So we're going to say 4 times r we're given is 20 times 20 divided by 3 divided by pi, and that's equal to 8.48. But that's just that distance from there to there. To take us back to the datum, we need to add this entire 40 plus that 30. So on this answer, we're going to say plus 40 plus 30. That gives us 78.84. Take that 78.84. We'll round it off to 49. Okay. Now we need to look on the y-axis. Okay. Starting at A again. We know that the distance from there to there is 1 over 3, as we had discussed here. So we're going to say 1 divided by 3 times the height we're given is 35 of the triangle, times 35. And we get 11.67. Take it, write it down here. Okay, now B is a rectangle, and it's just at height of half of 40, which is 20. So take a 20, write it down there, and then the next one is C. C is that triangle there. So from there to there, we discussed it, it's 1 over 3. So we take our calculator again, go 1 divided by 3 times the height of the triangle is the height of 10. And we get 3.3. But to take us back to the datum, we need to add this distance here. And we are given it is 5. So we're gonna say plus 5, and we get 8.33. Take that 8.33, put it there. And then of D, we discussed it before, that centroid there is at a distance 4r over 3 pi. So take our calculator. 4 times r is 10 divided by 3 divided by pi. We get 4.2. But that's that distance from there to there. We need to add from here to here. Takes us back to the datum, so we're gonna add plus 40. It gives us 44.24. Write it down here. Right, and then the last one is E. E is this one. It's just basically the radius, which is a distance of 20. So we write the 20 here. Right, the rest is much more simpler. We just need to look at the table. A times X. So it's area times the X part. And it's in millimeter cubed because I'm multiplying a millimeter squared times a millimeter. So for the first one, we're just simply gonna say 525 times 20, and we're gonna get 10,500. Write it down here. The next one is gonna be 1,600 times 50, 80,000. The next one is negative 75 times 47.5. We get negative 3562.5. Okay, the next one is 157.08 times 40. You get 6283.2. The next one is 628.32 times 78.49. Get that big number there. $49,505.33. Okay. The next one is A times Y. Area times that Y component. First one is 525 times 11.67. We get 6126.75. The next one is 1,600 times 20, 32,000. Next one is minus 75 times 8.33 minus 624.75. The next one is 157.08 times 44.24. Get 6949.22. And the last one is 628.32 times 20. Get 125.66.40. The next thing to do is to sum our area, the total area, which is this column. It's 525 plus 1,600 plus, or let's just say negative, minus 75 plus 157.08 plus 628.32. We get a total of 2835.32.